There are several methods that we can use to find the integral of a more complicated function that is not covered in the basic formula like the one we see down here. The first one that we're going to talk about is called the U substitution technique. The formula looks like this, but you don't have to remember it. The important thing is that we will usually let U equal to something, so this U should be some part of the integral where du appears, du also appears in the integral. For example, if I look at my part A here, I can let my u be x cubed x cubed minus 2 here. So my u is gonna be x cubed minus 2. So if I find the derivative of this thing, this is gonna give me 3x squared dx now, which also appears in the integral. So that's the latter part of the integral here. Now let me note about something real quick. When I take the derivative of this u, I'm gonna have this dx as well because, well, if you think about it, if I think of u as a function here, normally, let me kind of put this to the side. Normally, we will find du by dx, right? And that's gonna be the derivative of x cubed minus 2, which is 3x squared. Now I can move my dx to the other side, so I can write my du to be 3x squared dx, and that's going to be what's happened here. So my du is going to be 3x squared dx, which is what we have also in the integral. So I can now rewrite this integral as the integral of u to the fifth times du. So this is just 2 to the fifth du, and we can integrate this function now. The integral of u to the fifth is just going to be u to the 6 over 6 plus c. And because my u is x cubed minus 2, right? So I can make it substitution back. So that's going to be x cubed minus 2 to the 6 divided by 6 and then plus a constant c. So here's my answer for part A. Let's look at part B now. I have 2x divided by x squared plus 1. Notice how the derivative of x squared plus 1 is just going to be 2x, the x that we see up there. So now I can let my u be x squared plus 1 here. So my u is just going to be x squared plus 1. And then my du is just going to be 2x dx. So I can go ahead and make the substitution. This is going to give me, let's see, it's going to be the integral of 2x dx is just du. So it's going to be du over u. Or it's just going to be, well, let me write this as 1 over u times du. So the integral of 1 over u is just going to be log of absolute value of u. So I'm going to have log of absolute value of u plus a constant c. And because I knew that my u is x squared plus 1, so I can substitute back, and that's going to give me the log of x squared, log of absolute value of x squared plus 1, and then plus c. So here's my answer for part B. For part C, I want to integrate the square root of 3x minus 1. So this is basically 3x minus 1 to the 1/2. So I'm just gonna let my u to be the thing inside the square root here. So my u is gonna be 3x minus 1. And my du is gonna be 3. Well, the derivative of 3x is just gonna be 3 dx, right? Notice how, well, we don't see number 3 in my integral, but 3 is a constant, so that's okay. So I'm just gonna move 3 to the other side, so my dx is just gonna be du over 3, or 1/3 du, and I can substitute this into the integral. So this is gonna be the integral of the square root of u, because my u is 3x plus 1, 3x minus 1. And then my dx, I knew that my dx is du over 3. So this is going to be the integral of square root of u times du over 3. Now over 3 is a constant, so I can pull it out from the integration. So that's going to be 1 over 3 times the integral of u to the 1/2 du. Now I can integrate u to the 1/2. So it's going to give me u to the 1 plus 1/2 is going to be 3/2, and then divided by 3/2, and then plus c. I can simplify this a little bit. I can bring 3/2 up to the numerator, so that's going to give me 2/3. 2/3 times 1/3 is going to be 2 over 9 now. 2 over 9 times u to the 3/2 C. So that's my answer for part C. And let's look at part D now. I have sine x times e to the cosine of x. So again, I'm just gonna let u be the troublesome part, which is the cosine. U is going to be cosine of x. And then the derivative of u, the derivative of cosine is gonna be negative sine. So this is gonna give me negative of sine of x dx now. So notice how the derivative of u kind of appears in the integral. I just have to deal with the negative sign here, but that's not that hard. So if I were to rewrite this integral, I will have, let me see, I will have sine of x dx, right? So I'm gonna move the negative sign here to the other side. In other words, sine x dx is gonna be just the negative du. So this thing is going to be negative du. Just negative du. And then e to the cosine of x is just going to be e to the u now. So this is going to be e to the u times negative du. In other words, this is going to be, I can pull out the negative sign. So that's going to be the negative of e to the u du. Well, the integral of e to the u is just going to be e to the u. So this is going to be the negative of e to the u plus c. And I can substitute x in back. So by the way, I forget to do that for the part c. So let me kind of do that now. My u is 3x minus 1. So this is going to be 2/9. Let me write that here. So this is going to be 2/9 times u, which is 3x minus 1. Raised to the 3/2 power and then plus c. And also for part D, this is going to be negative of e to the u, which is cosine of x. Negative e to the cosine of x plus c. So this is the integration by u substitution.